Hello everyone. Welcome to another lesson from Edu Plus One. Today's topic is binary search technique. Binary search is a faster searching algorithm than the linear search. It works on divide and conquer method, and the prerequisite to apply this technique is that the list should be sorted. Now let's have a look at the list that we have created for you. The list is a sorted list. It is in ascending order and the elements are 10, 14, 19, 26, 27, 31, 33, 35, 42 and 44. As you know, in a list, the index of the element starts from 0. So there are indices that are starting from 0, then 1, 2, 3, 4, 5, 6, 7, 8 and 9. So the lowest index is 0 and the highest index is 9. Now let us see how do we apply this binary search technique to search the data element 31 in this array. And also keep in mind that the list L, which is going to be in this algorithm, is a sorted list in ascending order. And now I'm creating the list in Python. L is equal to square bracket, then the different elements and square bracket ends. As you can see in the diagram, the lowest index, which I am calling it as low, is 0 and the highest index calling as high is 9. Now let us find out the mid value, that is the middle index, right? And the middle index will be, the formula is low plus high divided by 2. So in this case, substitute the values 0 and 9 as low and high. So 0 plus 9 divided by 2 is 4. Please mind it that the division should be the integer division. So here is our list, and now let us compare the value stored at location 4, that is the new mid, with the value which you want to search, which is 31. But it is very clear that A mid, that is A4, is not equal to 34. It is a mismatch. And we also know that the value 31 which you want to search is definitely on the right hand side of 27, since the list is sorted in ascending order. So what we have to do is, we have to change our low, that is 0, to mid plus 1, that will make it as 5. So new low is going to be 4 plus 1, which is 5, and high will remain as 9. As you can see in the diagram, we are shifting low from 0 to 5 just to make sure that our new list is between 31 to 44. So we are going to divide our list into two equal halves. Now next is that we want to find the new mid. To find the new mid, we are going to apply the same formula, which is lower bound plus upper bound divided by 2. So the mid is going to be 5 plus 9 divided by 2, and the answer 14 by 2 is 7. So now the next thing is that we are going to check that is our L mid equal to number to be searched or not. You can see very clearly that L mid is 35 and number to be searched is 31, which is again a mismatch. Here is our new list in which mid value is 7 and A mid is 35. As you can see, an arrow points there. The element to be searched is 31. So what's the next thing that we have to do in this algorithm? Since we already know that element to be searched 31 is on the left side of 35, so there is no need to look beyond 35. So what we have to do is again cut the list in two halves. But this time, since we are very sure that the list is on the left side of 35, so let's change the upper bound, and what we are going to do? We are going to change high. So high will become mid minus 1, which is 7 minus 1, which is equal to 6. As you can see in the diagram also, we are changing mid from 9 to 6. And now the list only contains two elements, 31 and 33. So either the element is there or not there. Rest of the list is already finished. Let's find out the new mid again. And new mid is again the same formula, which is low plus high by 2. And the formula is 5 plus 6 divided by 2, 11 by 2, which is 5. So our new mid is 5. So again we have to check, is my L mid equal to 31 or not? And the answer is yes, because L5, which is a new L mid, is equal to 31 and we have found the element. As you can see in the diagram, the L mid is equal to 31. So this is how we are going to apply binary search technique to search a number. There are few points which should be noted in case you get any other kind of condition and you want to apply the binary search technique in that. The different conditions are that in case the element to be searched is not present in the array, then what would be that condition? In that condition, you will definitely reach a point where there is just one element in the list and either that element is present or not present. Now, in case that element is not present, then definitely your low, that is the lower bound, is going to surpass high. And this you can check in the while loop, that as long as your low remains less than or equal to high, you continue your algorithm. The moment low becomes greater than high, you can stop your algorithm and say that element is not present. Here is a function def binary search which we are going to apply for this technique. This is in Python and there are 4 parameters, the list L, the number num to be searched, low is the low index which is 0 in this case, high is the highest index which is 9 in this case. What we are going to do in this function is that we are going to put everything in a while loop. And the condition is, as long as my low remains less than or equal to high, we are going to continue with this logic. So in a while low less than or equal to high, we are going to find the first middle value, mid, which is the integer value of low plus high by 2. As you can see, double slash gives the integer division. And then check, is my L mid equal to num or not? In case it is equal to number to be searched, I am returning the mid value, which is the position of the element which you have found. Or there is a match. So wherever there is a match, you are finding the index value of that. Right? And in case you don't find the number, what you can do is that you can just check whether your number to be searched is greater than L mid or it is less than L mid. In case it is greater than L mid, definitely it is on the right side of the list or on the right side of the middle value, so you can change your low as mid plus 1. But in case your number is less than L mid, then definitely it is on the left side of L mid. So what you can do is you can change your high to mid minus 1. So in that way you will get the list into half. Now again apply the same thing because it's a while loop. So it will go back to the while loop. It will again check that the new low or the new high, does it suffices the same condition, that as long as the low is less than or equal to high, you have to continue with this loop. So again find the new mid with the new low or new high, whatever you got. Again check, is it equal to number or not? Again check that the number is greater or less, and you keep on doing this as long as there are 2 conditions. First thing, if you get the number, it will come out of the function and return the mid. If you do not get the number, this loop is going to terminate, and the while loop, when it comes out of while loop, you are going to return minus 1, and minus 1 will indicate the number is not present. Now let's see the main program. In this code, we have generated a list L, and these are the elements of the list. Same the elements we were discussing in our algorithm. The number to be checked is 26 in this case. Low is 0 and high is length of L, that is the highest index. In this case again it is 9, and we are applying the function binary search with all the 4 parameters, the value of these 4 parameters given from this program. We already have the value L with us, num, low and high. All the 4 values, the actual parameters are going to be passed inside the function's formal parameters. And since this function is returning a value, either return mid or return minus 1, we are going to catch that return value in the variable position. And then we are going to print that element is found at position, and printing the position number. And of course, there is a message for the user that the position number starts from 0. So let's see the output. The output is element found at position 3, and since position number starts from 0, so it is 0, 1, 2, 3. You can see the 26 is at position 3.